Radius 1 is inscribed in a square and circumscribed about another square as shown. Which fraction is closest to the area to the ratio of the circle's shaded area to the area between the two squares? So since we know that the radius of the circle is 1, we can draw a line from the center of the square to the edge and label that as 1, and then draw another line at the top and label that as 1. And then to find the side of the square, we can notice that it's a 1, 1, root 2 right triangle. So if we expand this figure, we know that both sides are 1. And then if both sides are 1, we can figure out the hypotenuse by using the Pythagorean theorem, which we can write as x squared equals 1 squared plus 1 squared. X squared equals 1 plus 1, x squared equals 2, and x equals root 2. So this side is root 2. So if this side is root 2, we know that the lengths of the square are both root 2. And then we can then write that the square's area is going to be root 2 times root 2, which is root 4, and the square root of 4 is 2. Then to find the circle's area, we know that the area of a circle is pi r squared, and from here we know that the circle has a radius of 1, so we substitute r with 1. 1 squared pi equals pi. And then we're looking for the fraction that is closest to the ratio of the circle shaded area to the area between the two squares. So first, if we look at the circle shaded area, which we can write as part A, and then we're comparing it to the area between the two squares, which we can write as part B, we're finding the ratio of part A to part B. And then if we write it as a fraction, we have A in the numerator and B in the denominator, since it's a ratio. And then if we look at the circle shaded area, we take the area of the circle and subtract the area of the square. And then that's this part we get from that. So if we do that, we take the area of the circle, which is pi, subtract the area of the square, which is 2. So pi minus 2 is the shaded area. And then next, if we find the area between the two squares, we know that this large square, we can find this side using the circle we have been given. The circle still has a radius of 1, so we can draw a line from this side to the center and label that as 1. So we know that this side is 1, this side is 1, so the diameter of the circle is 2. If the diameter of the circle is 2, then the length of the square is also 2 and 2. So the area of the big square we can write as 2 times 2, which is 4. And then next, if we're finding the area between the two squares, we're finding this region right here. This whole area. And then to find that, we know that the area of the big square was 4, and then the area of the small square is root 2 times root 2, so we know that the area of the small circle was 2. So we take 4 and subtract 2. So 2 is the area of these regions inside the big square. And then we know that the ratio of A to B is A in the numerator and B in the denominator, and we know that the shaded area was pi minus 2, so we take pi minus 2 in the numerator and 2 in the denominator, and we can simplify pi to 3.14 minus 2 over 2, and that's about 1.14 over 2, which equals about half. So we know that A is our answer.